So I'm here to introduce MGL to you. So MGL is a toolbox quite similar in some respects to Psych Toolbox. In fact, a bunch of us who were postdocs in David Heber's lab were a little bit frustrated with development on Psych Toolbox before Mario Kleiner took it over for Eli Mary and here and Mary says that well. Worked on this and we were just wanting to have an interface from MATLAB that we could use on OS 10. And the library works in some sense very similar to Psych Toolbox. There's a base library here, which has very simple commands that abstract in the original version of OpenGL functions, and you could display something before in a few lines of code. It has a extensive amount of documentation, which we created over the years, which you can find in the following wiki, which has examples and different things that you might want to be able to do, and you can download it from that website as well. The other piece of the library, which is a bit different from Psych Toolbox, is there's a task library. The task library is built on top of MGL, and the idea of the task library is to make it easy to prototype and run experiments where you have trials and segments within trials. Again, there's a lot of documentation about how to use that. Give you a flavor of how it works is that there is a few lines of code that you will set up that tells you about like whether the segments and timing of a trial or the parameters that you might have that you want to randomize over and when you want to acquire subject responses. And then you write very simple callback functions like what you want to do when you want the screen to display something, or how you want to do displays, and what you want to do like when a subject responds to a particular part of it. This task library, and then the rest of the task library takes care of all the rest of it in terms of timing, keeping, saving all the data, and integrating with eye trackers and the MRI scanners. This MGL in the task library is tightly integrated with another set of tools that originated in Brian Mondell's lab at Stanford called Vista that David Eager took to NYU called MR Tools. And MR Tools is a package for doing fMRI analysis rather than copy PRF measurements back and maybe things. And the MGL library is highly integrated with that. So when we run experiments with MGL, you can export all the different variables and timing to ML tools and be able to run fMRI. A few years ago, some of you may know, Apple decided to deprecate OpenGL, which is the standard for doing graphics that almost Psych Toolbox, MGL, others have been using, in favor of a library called Metal. And Metal is Apple's version of a low-level graphics programming language. We decided that we would try and see what we could do with that. And so we built a new version of MGL, which uses the same functions. So from the MATLAB point of view, nothing has changed. But underneath, we connect to an application that we built and developed that's based on Metal. Metal, the advantages of Metal is that it really allows you to do programming on the graphics card level in a way that Apple has specified with the library. So many things are possible there. A few things that we've done is, for example, some of these things took a long time for Apple to be able to get with everybody else and have a high bit depth displays where you can have more than 8 bits per color channels, and you can do those things quite easily. The thing that we're most excited about now is work that DJ has been supporting as a community project with the support of Ben Geasley, who's a programmer, is in trying to get more frame accurate timing using Metal. So one of the real advantages of Metal is it gives you time sense for every moment within your graphics rendering pipeline that are highly accurate. So this is just depiction of the things that Ben has been working on. So on the right is some display, we're just randomly drawing polygons and looking at the timing. There's a lot that's being shown on this, but you can see the different fragment encoders and vertex encoders, timing that it takes to do them, especially important is the time that it takes to render the frame. And you can see, particularly when there might be a drop in the frame is reported. So in this example here, there's one frame that's being dropped, and you actually get reported values that are quite accurate about that. So if you do happen to miss a frame, and that's important to you for say analysis or white noise kind of analysis, you're able to know that happened and then be able to account for that. That's it. Thanks.